I have loaded the sketch onto my Arduino with the screen attached, and I have plugged in the 9-volt battery because I want to record the positions of touches based on the 9-volt supply rather than the USB supply. I clicked at every black dot on the screen, which are the black coordinates, and every time my little program gave me the coordinate, the corresponding touch coordinates. Now what I'm going to do is I'm going to use these touch coordinates to map the X value touch coordinates to the X value display coordinates. And then I'll do the same thing for all the Y value touch coordinates to the Y value display coordinates. We will see that in the next video. We'll use Desmos to do the quadratic regression. Now in my browser, I will go to desmos.com/calculator. You can use this without an account, but if you want to use this in the future, you may want to create a login so that you can save your projects, your calculation projects. The first thing I'm going to do is I'm going to create a new table. This lets me put in X values and Y and their corresponding Y values. Now I have one done here for all the data, so we're going to look at that one. So the top table I've created here are all the X touch coordinates that map the X screen coordinates. So when I clicked 897, I was trying to click on the 20 X coordinate. So even though we're saying X1, Y1, we're really talking about an X value for touch creating a corresponding Y value, which is really an X value for the display. So the display is like the dependent variable where the touch is the independent variable. So I've entered all my X coordinates from I made a little note on my piece of paper to show what all the coordinating touch points were. So I'm entering all the touch points and the corresponding display points. These are for the X values. So if I were to click on that, you can see all the plots pointed here. Now I'm going to do a quadratic regression to get a model, a function that will give me the display point corresponding to a touch point. The way I do that is I go to the plus sign and I want an expression. So to do a model, I will say, now I'm going to move this up so it matches with the other table and it's easier to see. So to make a model, I don't say y equals, I say y tilde. So I want to map the y ones, I want to get the y ones from the x ones. So I say y1, and then I say the tilde sign. And for a quadratic relation, it's a times x1. Now I need a squared operator, so I go to my little keyboard and I pick the a squared. And then I say plus bx1 plus c. Just hide this for a minute. Now I've got a line that is a regression model for those points to try and fit those points. Now right here it looks like it's a linear relation, but if I scroll out, you'll see that it becomes quadratic. And my experimenting showed me that the quadratic relation was the best model. So now I have some coefficients I can use in my sketch to accurately map my touches to the places on the screen. My A value is this number here, my B value is this number here, and my C value is this number here. They are the coefficients of a quadratic model that will give me an X value based on a touch value. So a display value based on a touch value. Let me just hide these for a second. Now we'll talk about the Y coordinates. So this second table, these are the Y coordinates that correspond to the Y display coordinates. So Y touch coordinates, Y display coordinates. I'll turn them on so you can see them. Now I'm going to do the same thing. I'm going to add a model. So I'm going to pick an expression. Now I'm doing, these are X2 and Y2, so I'll say Y2 tilde AX2, and then I'll go back down here and grab my squared operator, plus BX2 plus C. So now I have coefficients for a model for mapping the y values. And again, if I zoom out, it looks linear when it's zoomed in, but as you go out, you start to see that it's definitely a parabola. It's definitely a quadratic relation that is the best model for this data. So I will now use these values in my sketch for the coefficients for calculating y touch values from y display values from y touch values. We'll continue that in the next video. We are now inside the grid alignment sketch that I'm providing, and we are adding in those coefficients that we calculated using the Desmos program. If we look at these variables here, these are the x coefficients for calculating x display values from x touch values. The x9 variables pertain to 9-volt power supplied to the Arduino. The x5 variables pertain to 5-volt, so plugged into the USB, sampling when you plugged into the USB. In our example, we did the 9-volt ones. So these are the A, B, and C values I got from Desmos in the previous step. And then further down here, we have the Y coefficients. So here are the A, B, and C values we got from the Desmos regression in the previous step. And then these are Y values I did earlier from another regression. Now I won't go into the regular part of the sketch here, but we'll just look at the part of the sketch that uses these coefficients. So when we look down here, once setup runs, we call this method called set equations. And what it does is it sets the coefficients we're going to use based on whether we're using 9-volt or 5-volt. So if we go down here to the bottom, it's just a simple little method that just says if the voltage value in the variable at the top is 5, we use the 5-volt coefficients for our A, B, and C values. And if it's 9, and otherwise if it's 9, we use the 9-volt coefficients. And then ultimately, when you click a touch, it calls this method called map2d, where it brings in x and y touch points and then uses them. This is a times x squared plus bx plus c. So this is just using a quadratic function to now calculate the touch point, the touch x value the display x value from the touch x value, the display y value from the touch y value, and then I just round it to the nearest whole integer, and that way the px and the py are what will be displayed on the display. So what will be used on the display for displaying a dot or text or a shape of some kind. But this now more accurately maps your touch points to your display points.